Hey everyone, it's Mr. McMahon again, back here with moles and representative particles today. So, what is our goal today? Well, our objective today is to use the representative particles, which are molecules, atoms, ions, formula units, or units of formula, to convert between these things, these representative particles, and moles of a substance. This means we need to be able to solve for both the representative particles and the moles. Now, if you remember in the last video, we converted between grams of a substance and the moles. Now, we're going to be doing the exact same thing, but with differing number of representative particles. And in actuality, this one's going to look a little more difficult because of the big 6.02 times 10 to the 23rd big number thing. But it's the same every time. You don't have to figure out the molar mass like you did before. You are just going to use 6.022 times 10 to the 23rd every single time. So the concept itself does not change. You will still find either multiply or divide just like you did before. This time, instead of using molar mass, we will use representative particles. So an example might be, how many formula units would there be in 3.00 moles of Mg3PO42? So think about that. I am asking you how many formula units. Now before, when we did this, we looked at the molar mass. So we had to look at the 3 Mg's, the 2 P's, and the 8 O's. But you don't need any of that. Because all you are looking at is how many representative particles you have. So, in this example, we see formula units. That is the representative particle. So 1 mole is always equal to 6.022 times 10 to the 23rd representative particles, in this case formula units. So that is all I need to know, is this right here and 1 mole. So what do I do now? Well, just like before, I know that 1 mole of Mg3PO42 is that. So first, write out what you're looking for, then write what you were given. Same as with the molar mass problems. So I want to know how many RPs are in 3 moles. So I look. Step 1. X formula units is equal to 3 moles of magnesium phosphate. That's it. That's the first step. Then I do that times line thing and I make sure I have conversions. So let's take a look. Using what I already know, I know that the units of formula from the mole conversion is going to be 1 mole and 6.022. So I take that idea and I have moles, so automatically moles goes on the bottom. It's going to be 1 mole down here with what I want on top. So as you see, 1 mole with 6.02 times 10 to the 23rd. Now I have to decide, am I going to divide? Am I going to multiply? Well, always we take this here, multiply it, and then divide. Well, when you divide by just 1, it's not going to be anything other than what you had before, so we just multiply. So 3 moles times 6.02, cancel out this mole with this mole here, and I get 1.81 times 10 to the 24th formula units. Notice, I just multiplied. Now, you might be asking, well, why is this 10 to the 24 if this was 10 to the 23? Well, when you multiply through, you actually would have gotten 18.1 times 10 to the 23rd. I always need the decimal in this second spot. So once I moved it over 1, it became to the 24th. Now, if you have a calculator that has the exponent button, you can use that. Or you could use a calculator that doesn't and just do the manual conversion. So now moles from, that's representative particles, forgot to change that. So you know that 1 mole of magnesium phosphate is 6.022 times 10 to the 23rd units of formula. So that's what I'm going to need to change. And in order to change that, what am I going to have? Well, sorry, went the wrong way. What I'm going to have is what I'm looking for and then the given. So I want to know how many moles are in 3.022 times 10 to the 26th unit formulas of magnesium phosphate. Step 1, Just like before, I take my X moles because that's what I want, and I put what I am given. Does not change. Again, use what you already know. I know the conversion. So I'm going to get X moles is equal to 3.022 times line. Now, in this case, take a look. I put the mole on top because I want moles, so that 1 mole goes up here. On the bottom of my units of formula, I bet if I cancel them, I have 0 units of formula left, so I would take this and divide by 6.02. If you do that, you will get 502 moles. So in conclusion, if you are given representative particles, then you divide by 6.022 times 10 to the 23rd. And if you are given moles, then you multiply by 6.022 times 10 to the 23rd. And no matter what, 1 mole will always be 6.022 times 10 to the 23rd. It's your turn. How many moles are in 5.69 times 10 to the 24th units of formula of sodium hydroxide? How many molecules, represented particles, are there in 9.87 moles of H2O? Please come with these in class tomorrow. Now, think about this as well. Why is the first one units of formula and the second is molecules? Think about that, and we'll talk about it tomorrow.